Hello. So this video is for the people who missed the first smart contract workshop and the second one where we kind of highlight what a smart contract is and how you can navigate it. So we're just going to highlight what a smart contract is and the language Solidity, which is used to create smart contracts. So the first thing is quick review. A smart contract is a digital contract stored on a blockchain that can be executed. So this is what a very simple one looks like. It's basically like most programming languages. You have functions. So at the very top, we'll just go through it from the top to the bottom. You have the code license, which basically describes what you can do with the code legally. So sometimes it might have MIT or GPL. Those are open source permissive licenses, so it's okay to use the code in your own contracts. If it's BSL, you probably cannot use the code because it's a business license. Usually they have a change date where it'll change from BSL to MIT, which basically means it'll go from closed source to then open source, and you can do whatever you want. The next is code version. This is the version of Solidity, which is the programming language that this code was compiled with. And so it has a little upwards caret. That means that this contract is compatible with all versions equal to and above 0.8.24. So if you had another contract that was 0.8.25 and you know, this one would work with that one. But if you had a contract that was 0.8.23, this one would not work with that one. And it would give you like an error, an reversion error. The next thing is the contract name. If you're familiar with Java, it's kind of like the class name. Pretty similar. And when you deploy a smart contract, it's kind of like you're instantiating the object. Next is the function visibility. This describes who can call that function. So if it's public, that means anyone can call it. If it's private, like it is done here, that means only this smart contract can call it. So I could call increment in this function, but you wouldn't be able to call increment. Next, there's a little detail. So public, anyone can call it. Internal means only this, and derived contracts. So if I have another smart contract that inherits this one, it's kind of like Java, then I can call internal things. But if it's private, only this one. The next thing is I got uint56 is the same thing as uint. So you probably notice like in this is a state variable that the contract uses. For storing data, you probably notice that it says uint256. That means an unsigned integer with 256 bits. This one is a get function. It returns a uint. Returns the same piece of data. It's because a uint256 is the same thing. When you say uint, it's assuming you're saying a uint256. These are state modifiers. So a modifier modifies a function. If it says view, that means it's a state modifier. It does not modify the state, but it lets you view into the current state. But if it's pure, it doesn't modify the state, and it doesn't view the state. So this one just adds these two numbers that you supply. But this one that says add with storage, it has a view because it has to read this state variable, and then it's adding this number. Yep, I said that again right there. And then just to go back, you have to mark what the variables, what you're returning as well, right here, with returns uint, returns uint256. So if I was returning two numbers, it'd be returns uint256, comma, uint256. Value types versus reference types. This is other similar to other programming languages. Value types are if you have a variable and has a value of 1, 2, -3, then that variable just directly corresponds to that number. If you have a reference type, which could be an array, a struct, or a mapping, then that variable would point to where you can find the rest of that struct, array, or mapping. And even more examples of this, like this one. So again, here, MIT, that's a license. That's the version. This is our state variable. It's in storage, so it's going to persist. So if I change this in one transaction and then come back to read it in another, it'll still be changed. If I change it again, it's going to persist. This represents the array in memory, so it only exists for that function. So this one exists in storage, this one exists in that function. And then this array exists within the call data. Call data is basically the same thing as memory, but you can't change it. It looks different in other programming languages, but it's pretty simple. I have a little thing right here. It's basically only used in function, cannot be modified. And then I just want to highlight With reference types and arrays, it's the same thing as the languages. If I have an array for A that's too long and I make the first one 10, second one 20, and I set B as A and I change B0 to 30, then it's going to end up giving me 30, 20 because this B points to this A. So that's similar how that's working. If you're familiar with other programming languages, if not, that's okay. You'll get familiar with this over time as you code more and more in Solidity. Here's structs and mapping. So structs is like a collection of data and types. It's very organized. And mappings are basically we go from one variable to another. Mappings are used everywhere in crypto and Solidity. And you'll notice that it says public. That means anyone can call to read from this mapping. If that public wasn't there, then you couldn't call and read from it. We have an add person public function where you give them a name and an age, and then it marks that message.sender, which is the person that called this function. It marks and it sets them in this mapping, their name, their age, and who called. And then you can do get person, which as you see is a view. And so that one reads the state of the mapping and it returns their name, age, and wallet right there. Name, age, wallet. Yeah, mapping is keep track of individuals. So like if you're making a token, the mapping will keep track of balances. If you're making a lending protocol, your mapping might keep track of debts. If you're making a perpetual protocol, you might keep track of position sizes, leverage, whatever. So let's talk about what a token is. A token is just a smart contract. If you've ever heard of the Shiba Inu token, Chainlink token, I don't know, Uniswap token, Wrapped ETH, those are all smart contracts. And so all they're doing is really storing someone's balance in a mapping. That's all they're doing. And so OpenZeppelin is a company that produces smart contracts that you can use on your own. They do it for free. They make money through other ways. But anyways, they provide a free service by providing these smart contracts. So here I made one called test token, and it mints the message.sender, the person who created it, 4,000 tokens. And you have a function mint, which mints to this address, this amount right there. You probably notice it has a modifier of only owner. This modifier came from the ownable smart contract, which my token inherits. And basically the only owner just says, whoever created the smart contract, only they can call this. So let's say we want to build a marketplace where you have Shiba tokens and I have USDC, and I want to purchase your tokens. But the problem is that what if your creation of how you made a Shiba token looks different than my creation of how I made my USDC token? So, traditionally you need an escrow to trust each other. But if we can use smart contracts, that'd be better because then we don't have to trust either person. But the issue arises in how can I be sure that each token has the same methods and the same everything? Because what if I use transfer to send you tokens, but you use transfer to? It's the same exact function, but it's spelled differently. But then if I were to make a smart contract, do I call transfer? Do I call transfer to? So this is, how do we know what tokens are supposed to look like? This is where ERC comes in, and these are Ethereum requests for comment. These are basically the standards for where all code is defined. So if I go to this website, you'll see a bunch of proposals. This is where all of our standards come from. If you've ever heard of ERC20, that's a token standard. ERC 721, NFT non-fungible token standard. This is where we define the standards for how the code should look. These are super important within crypto. And it's also kind of a testament to the community because as you can see, there's just a lot of different standards that exist. There's still standards coming out that are being produced, and it's all very interesting. Yeah. So if you ever are curious, you can always explore that page and check out any new standards. But this is where we're able to know for sure that your ERC20 standard will work with everyone else's, like in a marketplace. So okay, now our goal is to install stuff, which you will watch in the next video.